My name is Jonathan Creamer. I'm a senior engineer at Microsoft. That's us at Disney World a few weeks ago. We're huge Disney people. I'm basically jcreamer898 on all the main social networks you'd want to see. And yeah, I'm excited. I blog. You can follow me at jonathancreamer.com. Blog about a lot of the stuff I talk about here. And Node, JavaScript, TypeScript. Huge TypeScript fan. And yeah, I'm just going to kind of jump right in here. So the first thing I want to kind of talk about, because it may not be a concept that's familiar to everybody, is this concept of having an engineering system at your company. It really only comes after your company is at like a specific size, like a huge scale, to where you need a team that actually builds the tools you use on a day-to-day basis. It wasn't really till I got to Eventbrite, where I was working with Ben and Kyle, where we had a front-end infrastructure team that we actually needed it. And I really like, we have a big team at Microsoft that Peter works on called 1ES, and it stands for One Engineering System. And this is just a couple quotes that kind of talk about what an engineering system is like. We provide tools and services to cover the full spectrum of the engineering lifecycle, from the desktop to the product deployment. So that's what they cover. They focus on engineering systems that scale, because there's just a huge amount of problems. We'll talk about some of the kinds of problems that we see at the type of scale we're talking about. And we try to do it on top of retail developer tools, particularly in the front-end space, open source tools, and use those open source tools to build huge scaled front-end engineering systems. So in terms of the types of things that I deal with at a front-end engineering systems level, our team is called 1JS, sort of a pun on the 1ES, and we deal with all of these problems at scale. So these are all the things that we as a team have to have kind of in our mind thinking about at a huge scale. Starting with your local dev. We call this inner loop at Microsoft. This is on your local machine. This is yarn start. This is dev server. So it depends on what dev server you're using. You're using Webpack, you're using ES Build, you're using Vite, using whatever. So we help maintain the set of configs and startup scripts to help people work locally. The next is your CI/CD, continuous integration and deployment, and that's where you're talking about outer loop at Microsoft is how we call that, and then that's like your Azure DevOps. Are you using Jira? Are you using Circle CI? I actually meant to put Circle, not Jira there. That's slightly different, but Circle CI or whatever sort of Jenkins, whatever system you're using. Are you using YAML? Are you using Groovy? Are you distributing with containers? So those are all things that you have to know about as an engineering systems team. You've got things like test automation. You're running unit tests end-to-end. Visual regression testing, which is it's a little bit newer type of testing than I'll show later. It's becoming really popular. And my slides are just going to restart, but that's fine. Let's see, we'll give them I just need to not move. If I don't move, it won't do it. There we go. We talk about build and bundle. Are you doing Webpack? Are you doing Babel? Are you doing ES Build? Again, some of those tools. Publishing to NPM, publishing to CDNs. Validating, doing Prettier, ESLint, dealing with version control. We're in a monorepo in our particular space, but in other engineering systems tools, you got to worry about lots of repos across teams. Yeah, so that is a lot of stuff for a few people to have to manage. And it's sort of funny because when I was at Eventbrite, Kyle and I sort of joked like we're front-end developers who don't write front-end code. We're actually spending most of our time in YAML and in Docker containers and all these other tools that aren't actually JavaScript. We do use TypeScript and Node to build tools, but like, are we front-end developers? I don't know. So we actually asked the question on Twitter, like, what are we? Are we front-end engineers? Are we front-end DevOps? Are we front-end SREs? And we got, the most popular answer was front-end DevOps. But then out of nowhere, this guy Enrique came up with my favorite answer, which is front-end engineers who manage infra should be called DevOps engineers. And so we just loved that. And so if you search Twitter for DevOps, that's sort of like Ben, Kyle, and I sort of started that whole thing on Twitter. And we have like a Discord community. We talk about that kind of stuff. And I wanted that to be, because I think like the thing that drives me the most crazy about front-end engineering systems is that every company seems to have their own methodology for doing it, just slightly differently. Just changing configs here and there. But basically, everybody's doing the same things to different companies. So I've been trying to get the community to sort of rally around, a concept of DevOps or whatever it's going to be. So that, anyways, so yeah, DevOps. I thought that was a really funny one. And we're just going to keep just doing this, which is fine. It is what it is. Cool. So on our team at Microsoft, what we're up against is a monorepo that has 1,500 packages, give or take, spread across 2 projects right now. And it's about 10 million lines of code. And it's broken up into all kinds of things, mostly TypeScript, obviously, and JavaScript, all kinds of stuff. I'll show a screenshot of that in a minute. We have 1,000 plus developers working in that ecosystem, about 800 unique committers a month, so tens of thousands of commits come into that system. We do a TypeScript, JavaScript, and then crazy enough, a lot of our web components are wrapped with iOS and Android using React Native, and we ship those out all over the place. Just my team, or my One.js virtual team, is spread across from Vancouver to Redmond to Nashville, where I live, to Oslo, Norway, to India, or to Africa and India. And so it's like 50 of us scattered all across the globe, just maintaining this one engineering system. So like I said, we are in a huge, I don't know what is going on with this thing. I'm using maybe I should just switch to a different thing. I don't know, it's fine. Okay. So we are in a monorepo with hundreds of other repos oncoming too. That's actually the Africa team's entire job, is to find other repos at Microsoft that are good candidates to come join us in our monorepo. So we have even more coming. And we have to share a lot of the code from the monorepo to other parts of Microsoft too. So that's another thing that we have to deal with. So this is sort of a snapshot. You can't even see it. It's ridiculous. It's like 8.5 million lines of TypeScript, 2 million lines of TypeScript, Markdown, CSS, Less, C#, Python apparently we have. Apparently somebody's writing a Vue component, which is funny. It's just insane. There's a ton of code in there that we have to deal with. So there's obviously a set of principles we have to follow to help scale that type of a system, because that is a really big system. So I want to talk about some of these principles that we try to follow. And so Alex, who is sort of, I call him the godfather of One.js, he works in an organization in Norway that was building a component that got shared all over the place. And he sort of realized that we needed to have a One.js engineering system to share all this code across Microsoft. And so one of the quotes I love from him is he says that the system should scale to the size of the coding scenario, not the size of the repo. So it should scale to your use cases. It should scale to your search app or to your live persona card that we're going to talk about in a minute, and how you deal with those particular engineering system scenarios, and not with like the actual amount of code that's in the repo. So I love that one. Another thing we talk about a lot is this idea of falling into the pit of success. And what that's basically talking about is that a well-designed system should make it easy to do the right things and really, really annoying to do the wrong things, if not impossible in most cases. So give people the easy way so that that's always the right way. You know, if they're not finding success on their own, as an engineering systems team, that's our fault. You know, we need to make the easy things the right things. So there's a whole article there you can check out called "Falling into the Pit of Success" by Coding Horror. Consistency always wins in a system of this scale. You have to work really, really, really hard to make things look and feel the same. That's another great quote. If you want to go fast, go alone. If you want to go far, go together. And so where we apply that principle is in an RFC process. So our engineering system doesn't change unless you have an RFC get approved by several members of the engineering systems team. Even my own stuff. If I have an idea how to change it, I submit it to the RFC process, and then all that big 50-plus team, we sort of talk about it and discuss all the ins and outs that could go wrong. We copied our RFC process from NPM because they were doing it, and we were like, hey, we should do that for ours. I think that would be really, really helpful. There's a whole nother article on another concept called ADRs that Spotify does. Those are called architecture decision records, and we really like that format too. An RFC is more of like, hey, I have this thing that needs to change, let's talk about it. And an ADR is like a decision that happened, like, why did we choose the monorepo? And so we'll write an ADR about why we chose the monorepo, as opposed to like, why should we use some new tool? Let's write an RFC for that. So every week we have an RFC meeting where different engineers come and present ideas about what they think the engineering system should do at that scale, and we just talk about it for an hour a week, and it's actually really fun. And so we have to do that every week. This is just crazy. The other thing we have to try to do is generalize the solutions because of the scale. We can't just have 10 packages out of 1,500 doing this one thing. Like, we want to try to make sure that the solutions that get presented in the RFC is something that could scale to the right size. So we have to make generalized solutions. Another concept that really, really helps, particularly in front-end monorepos, is this idea of thinking in packages. We're sort of used to this already, but I don't know that we really think about and internalize it all that much. But like in a monorepo with 1,500 packages, each one of those packages is the smallest unit of sharing, both in the monorepo and out of the monorepo. And we try to treat them like black boxes, almost like APIs, like Ray talked about with his Lego blocks. We use our NPM scripts as a way for us as an engineering system to tell the product teams, hey, if you guys just give us a build, a test E2E, a lint, and a bundle verb, we'll run that for you. We don't care necessarily what you do behind that. We do lay down a golden path for them, and have like certain scripts that we provide that we think you probably should be using this script to run your builds. You should probably be using Babel. You should probably be using TypeScript. You could use Webpack 4, but this also gives the teams a little bit of flexibility because there are a handful of teams at this size. Like, not everybody can always use the same build tools. There's going to be some team that's like right now needing to use Webpack 5, and we've got to support that use case too. But as long as that team knows what they're doing, they can just put their command behind the bundle NPM verb, and we don't care. We're just running the task scheduler, and it just does the work. And so that's sort of the API that our team provides to the product teams so that they can do that. And we use a library called Workspace Tools as well to help sort of iterate through the packages and that kind of stuff. So we basically turn our packages into an assembly line, right? Just give us all your 1,500 packages, and we'll build and test and do all those things for you so that you don't have to worry about it. And then on top of doing all that, we need to make sure that you're constantly measuring everything. And to the point where like you don't even start a new feature unless you have baseline metrics. That's the only way that you can guarantee that your change is actually going to have an impact, especially at the scale that we're at. We got to make sure that our build times are measured, that our pull request times, that our release times, all those things. And we actually pump a crap ton of data into something that we can query with something called Custo, which is a language that it's sort of like SQL-y. So that's one of the charts we've generated recently for something. So yeah, measuring things is incredibly important. Even if it's just Google Analytics, just measure everything, and don't even build a new feature until you have like that measurement set up. Another thing is communication is absolutely the most important thing you can do at a scale that we're at. Like if my team in Vancouver starts working on something and just kind of gets in a rut, and we don't tell the team in India about what we're doing, chances are they're going to maybe implement something the exact same thing we did or something slightly different. So communicate, and when you think you've done it enough, keep doing it. It's incredibly important. We have biweekly syncs that we do with our V team to make sure that I know kind of what they're working on, they know what we're working on, and it's a really, really nice way to make sure that we're all aligned and on the same page. And I'll just jump back over here. I guess I'm going to buy a different Anchor thing when I get back here. Here we go, and there we go. So I want to kind of go into some of the things that I find the hardest at a scale of our size. So one of the hardest things, and one of the reasons we even started off in creating this engineering system, is to share components. Oh my goodness. Okay. So like I was saying, Alex, his team in Oslo was building something called the Live Persona card. And that little avatar thing is a card that they built a monorepo around and ended up being lots of other things in it. But that card, there's a screenshot from Outlook, there's a screenshot from Teams, and a screenshot from, I think, PowerPoint. And so that card is written in one place, but has to be distributed all over the company. And so Alex was like, we've got to have like better ways of getting that code built, tested, and released all over the globe. And so his original idea to help with the sharing aspect was, let's build a monorepo, of course. Office is already one of the biggest monorepos in the world. And so their team partnered with Office, and they said, let's build like a really, really good JavaScript monorepo. And some of the reasons why we thought a monorepo would be great, you can do atomic changes. You can obviously have one group of changes per commit. So you can change like one package that depends on another, and you can change both ends of the dependency graph in one change. We like to have consistent tooling. It's really nice for no context switching. I'm not having, again, everything, once it's looking the same, it's just really nice because everything looks and feels exactly the same. And it makes it a lot easier to change everything across the entire ecosystem of the monorepo in a small amount of change. I'm sorry. You guys can just look at me. I mean, it's really not that interesting. I can just talk. There we go. Code reviews are centralized. That's another nice thing too. Like, you know, all of the code reviews for the system. This is just nuts. Do you guys have any idea what might be going on here? I don't know. Does somebody have a better? If somebody has a better hub, they can run up to me. That would be great. I'll just plug it in a different. If somebody has a different, yeah, USB-C. Okay. It's easier to stand up new projects. We have like a yarn generate command. You have like one that's just like mine. So we have a yarn generate command, so that way we can simply run and generate new packages. So teams don't even have to worry about like what a package looks like. They just say yarn generate, and they just get a new package to start working with. And those are the kinds of tools that my team helps build and maintain, so that way teams are just able to work. Because at the end of the day, the most important thing for the product team to do is to build product, right? And so we try to make it easy and get out of their way so that they can do that. Oh, I have to hit allow now. That's why maybe it didn't work earlier. Let's see. It's, the other thing that we really love, and one of the reasons, like with this live persona card thing is, if you want to change the live persona card and you want to see the like downstream changes, like if I change the live persona card, did I break other dependencies? That's really nice because you have a sense of the dependency graph. And so you're able to figure out like, well, I changed like this line of code here, and I can go test all the dependents downstream. And that is really easy in a monorepo because you have the nice dependency graph shared across tenants. Code discoverability, everything's in one place. And you have a single CI and for all your pull requests and releases. That's a really nice feature. And I think it also helps just create a culture. If everybody's in the same place, they're all using the same tools, there's no more silos, no more teams doing different things. If things just become easy, code developer mobility becomes easier. If you're switching teams, you're just literally able to just go to a different team, work on the same things. And then it has just a nice culture around it all. I put a couple of articles in there about Google, Facebook, and Twitter's thoughts on monorepos as well. And another thing I did, I just threw this in, I forgot about it, I was talking to Ray about it. I wrote a cool little VS Code plugin that gives you like a count of all the packages in your monorepo, gives you a dependency graph. It's called VS Code Monorepo Tools, you can check that out. Another way just to help us scale, so that way all the monorepo tools are just available. But what's crazy is, and a lot of people when you start talking about monorepos, they start talking about all the problems of monorepos. Well, here's the cool thing about that. We also solved some of that stuff too, because it's really, really hard to clone a really big monorepo because they get really big, because there's a lot of code in there. So what do? We just said, oh, we'll just go fix Git. How about that? So Microsoft actually sponsored some engineers. It must not have been my thing. I don't know. Microsoft actually sponsored some engineers to go to GitHub and literally fix Git. And so you started to see features like partial clone, where you can do the depth flag. You started to see things like sparse checkout. All those features came out of work that Microsoft helped do to fix Git, literally, to help support our Office monorepo, and then into the 1JS monorepo and all that stuff. So yeah. And then we also worked on another API, another CLI for Git called Scalar, which takes even more performance improvements and puts it into another CLI. And Scalar is actually shipping with Git now as well. So if you install Git for Windows or any, it's like a checkbox in there, like include Scalar. So yeah, he's got another. We'll just keep trying them. You know, if anybody else has a hub, you know, let's just keep seeing what we can do here. I don't know if it's like, surely it isn't like my computer. Could it be? I don't know. I don't think so. I'll unplug it, but I doubt it's that. But we'll just keep trying. Eventually it'll work, and we'll be fine. So Scalar is a really cool CLI that encapsulates even more performance. And then we also built something called Git Credential Manager Core and ship that with Git now too. So Git Credential Manager Core helps log in if you're GitHub, Azure DevOps, and automatically configures all the built-in Git performance for managing huge repository stuff. So yeah, I'm just like, oh, we'll just fix Git. So again, like I was saying, Scalar is just like an option now when you install Git. So it's really, really hard to build 1,500 packages, as you could imagine. And so we have a project that evolved out of some requirements for our monorepos called Lage. Lage is a Norwegian word. It started with Lerna. We were using Lerna at first in 1JS, which is, of course, everybody knows Lerna in the JavaScript community. It was one of the biggest monorepo management tools. It didn't quite cut it for what we needed. I'll explain why in a minute. We looked at Rush, which is funny because it's another Microsoft product by the OneDrive SharePoint team, but there was some too many batteries included type scenarios that we wanted to sort of reconfigure some things, and it was a little hard. This was a while ago. Rush has changed a lot since then, but Lage evolved out of some product needs that we had in 1JS, and one of the biggest ones was with Lerna. When you ran Lerna run build, it would it was cool in that it would topologically build all your dependencies and all these things. But you couldn't do like Lage or Lerna run build test lint to where as soon as your builds are done, your tests start running, and then your lint starts running all in one continuous build. And so Ken was smart enough to create a situation where you can say Lage run build test lint. And as soon as all your builds are done, your tests start running, and then your lint starts running. And it's this big, long build graph that allows your CI system to just kind of do it over a long period of time. And it can actually split it up into all the threads it needs on disk or on CPU usage. And I'll show a cool screenshot of that in a minute. And it optimizes for speed and scale as opposed to what Lerna was doing. And Lage v2 that he's working on right now is going to be even cooler because you'll be able to not only split down to the task level, but be able to configure your tasks to split out workers. So if you want to run jest across multiple CPUs, like the one Lage process can then spawn however many jest workers you need. So Lage is really powerful. And a lot of you may have heard of a monorepo tool called Turbo. And it's funny because Turbo is a Go implementation of a monorepo tool that basically was what Lage was doing. And there's a link to a GitHub issue that sort of talks about that too. So again, Lage formed out of the need for a product, and then it's now kind of evolved. But this is what I was talking about with the build graph. So each one of these is a thread, a CPU thread. You can kind of see it's like an npm run build, and then it just sort of started using all of the CPU threads to run all those different npm verbs: build, test, lint, test HUE, blah, 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 blah. And it sort of cascades them. So we're using these big 48-core machines, and you can dump a log too, a JSON log that gives you that, and open it in Chrome Developer Tools and see exactly how long your critical path is. So if we have one app taking 35 minutes to do a Webpack, we can go, hey, search, you need to go make your bundle not be 35 minutes. That's insane. So it's really nice in terms of Lage's just ability to log that out. And then Lage also, one of the things that is massively important at a scale this size is caching. So one of the tools that we built along with Lage is this thing called backfill. And what backfill does is, as a part of computing the graph of your build, it'll also go to the cloud and say, have I ever done any of these things before? Have I ever built this package already? Or have I tested this package already? And it'll just go download that cache off of the remote on a task-to-task basis. And so even if you are always building all 1,500 packages in a pull request, you're technically not, because you're only still building what changed according to your dependency graph, because it calculates the entire build graph and downloads everything on the fly. So it's fine. It's cool. And then we actually have another tool at Microsoft that we're onboarding now too, called BuildXL, which Lage powers. And BuildXL actually can do even more scaling. It actually is able to look at all your inputs and outputs and make sure that that you're always declaring your dependencies correctly and all kinds of other distribution things. And the reason why even vertically scaling can get you so far, you can go to 48 cores, 64 cores, but then eventually you might have to go out horizontally. So that's what BuildXL can handle. Our new task scheduler can not only use huge machines to go up and add CPUs, we can actually go out and have a bunch of machines doing work for us too, so you can distribute horizontally and vertically. And then we use that cache to make sure that everything still runs really fast. Another thing that's really hard is I could imagine you imagining that a monorepo is probably going to have a whole lot of yarn stuff to install, and that is a true story. It's about 8.5 gigabytes of node modules that we have to install, and we had gotten to the point where our regular yarn install was taking like 30 minutes. It was absolutely bonkers just to download all this stuff. And so my friend Vincent from Oslo worked on this idea of trying to sublinearly scale our install. So obviously sublinear, the amount of packages as it goes up, it still doesn't, dramatically increase the install times. And we heard of this new thing, and many of you probably heard of this thing called PNPM. And PNPM is another NPMe type thing, and it was really, really fast. But the reason why it was fast was because rather than downloading everything to the node modules directories, it actually downloads everything into one folder on your disk, and then symlinks all the monorepo's node modules into that store, which also has a side effect of breaking a paradigm called hoisting, which I don't know if you've ever heard of hoisting, but hoisting is this crazy bad thing that I don't know how we let fly in the JavaScript community for so long. In a monorepo especially, if package A depends on React 17 and package B just like forgot to add React to its package JSON, package B, even though it doesn't ask for React, is getting it because the other package is asking for it. And so that's not good, because if this guy bumps from 17.1 to 17.2, and this other guy's depending on some feature that was in 17.1, he's going to get automatically upgraded because he's hoisting to the root React, and his app breaks. So we built Midgard Yarn Strict, which is a fork of Yarn, which is hilarious, because we forked Yarn to fix some performance improvements, and then we forked it again to give our version of Yarn some PNPM-like stuff. And I'll show a screenshot of it in a minute. But what's really, really cool, though, because obviously when you start talking about a fork of a fork, that's like forkception, and that's really bad, and nobody wants to do that. But we decided to take our work on what I'm talking about and submit an RFC directly to NPM. And so there's a RFC that got accepted, and actually I believe is in some of the beta versions of like 18.19 or 8.19, I think, has this mode in it. So we actually got to work with NPM to provide this PNPM, like, yes, thank you. So what it looks like is how this works for us, and how it's going to kind of keep working for NPM. Where we download all of the dependencies, just look here. We download all the dependencies into the Yarn cache, and then we create a local dependency graph of our own with this crazy algorithm that Vincent wrote, and then we symlink. And that way we have this one folder called .store, and I think with NPM it's like .npm / or maybe it's node modules / .npm. So then all the stuff from the store gets symlinked into your node modules packages all across your monorepo, and it's really fast. So we went from like 30-minute down to like 8, and it's not ever going to like get any higher than 8, because that's the whole idea of sublinear scaling. No matter how many packages you add now, it's still going to stay consistent because of the duplication. Because of the fact that we have this big store folder. Even if you have 5 packages using the same couple versions of React, they all share that one version from the store. So it's really nice. So it takes care of an even higher level of duplication. And we also built incremental store into ours too, or incremental install, by making sure that we cache or hash all the things. And if you haven't changed anything, it'll take like 10 seconds to do the install. It just doesn't even do anything. So it's Midgard Yarn Strict has been really fun to work on. It took us a little while to get one of the hardest parts of it was it's a strict package manager. So if you don't declare your dependencies, your stuff's not gonna work. And that's actually sounds like an easy problem, but it's actually a really, 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 really hard problem because of this whole hoisting thing across the entire JavaScript ecosystem. There's just a lot of packages that you'll find out, like some Apollo GraphQL wrapper, has all their stuff in their package JSON except GraphQL, and they just like forgot to put it in there. And believe me, that has actually happened. And so we had to like go and fix tons of stuff. It took like 3 or 4 months to get that working. And that's not a problem just for us, by the way. That's a problem for anybody that's using PNPM in the true strict mode way that they can do. PNPM has this like a dangerously hoist sort of thing that you can do to opt out of that behavior. But it's really good because when you have a strict install, your caching is more reliable as well because you're always guaranteeing the same inputs and outputs. And so that's really, really, really important for us in our system. So moving on from installing, one of the other things that I've been just dying from is Semver, because that thing is like, I've been doing Node for a really long time now, and I swear Semver still trips me up so badly, especially at scale. So when you have a monorepo with 1,500 packages in it, you have to have a tool that uses something like conventional commits, or Atlassian has a tool called change sets, and we have a tool called Beachball, all open source stuff. And the idea behind these tools is, anytime I make a change to a package, I'm going to describe the packages that I'm changing as JSON and say, these 5 packages in my pull request are getting, this one's a patch, that one's a minor, this one's blah, 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 blah. And then what it'll do is when you run, you'll run that Beachball change command in our case and generate those JSON files. And then as a part of your release pipeline, it will calculate the changes that need to be made to all the packages. And so if I change, package A and I say that it's a patch, all of its downstream dependencies will get bumped as well to make sure that they're taking on the new dependency. And this is a really, really important part of this. But it also becomes really hard because when you get to a huge scale, you've got hundreds of commits, you've got thousands of people doing all kinds of stuff. And so Git conflicts are really hard because you have to commit those version changes back into main or put them somewhere. If you're constantly changing Semver numbers, you've got to put them back into source control. So we have this crazy release pipeline that we have hundreds of commits coming into. And so this is like release 1, release 2, and release 3. And so every one of those releases has bunches of commits that get batched into it. The release pipeline has to keep moving. It can't break, otherwise people can't ship code. You can cause things like logical merge conflicts can happen, which is really not much we can do about that, but it just happens. If Ben and I both have a commit in the same release to touch the same package, there's really not much you can do about that. We just have to find out about it later. But what we've had to do to solve our versioning problem is we have a main branch, and in there, we don't store the version numbers at all. There's just 0 to 0.1 for everything across the monorepo, which is fine, because for us in a monorepo, we're just trying to share code ahead. I don't necessarily need to know what version of my thing is in the monorepo, because it doesn't matter. I'm just working with whatever's in the monorepo, which is the whole point. I want to be able to just depend on the latest code of my button, because I just want to make sure that the button's good and that my search box is good and it's all ahead. So we actually branch off of main and do all of our work in a branch called versioned main. And in there, we have change logs and versions and all those things. And it allows us to never, ever have, or very, very, very rarely have Git conflicts because of a package JSON got changed in main, and then it got version bumped and blah, 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 blah. Like all the versioning just happens in a separate branch. So there's no Git conflicts. And then the other thing that we do is we branch off of the version branch so that teams can patch. And so every day we have like dozens of release commits that people can go check out that branch of and do a patch and get the code at that specific version and do patches off of that to push to NPM or Azure Artifacts in our case. So that's sort of our crazy versioning flow. It's much more complicated than that, but in a nutshell, that's the kind of things we have to do this stuff. Another problem with Semver is duplication. This might be really, really hard to see, and I'm sorry about that. I would love to zoom in, but if you look here, this is in Strappy.js. So there's Babel Core 7.18.10 and Babel Core Caret 7.17.9. Down here, these ranges are actually the same range as this one. And yet this one says 7.18.5 and this one says 7.18.10. And that's because Semver's weird. Like Caret 7.10.0 could be 7.15, 7.20, 7.21, and your yarn lock doesn't really move unless you tell it to. And a lot of people don't realize this. If you go look at your yarn lock, I can almost guarantee you, unless you're tuned into this problem, that you probably have tons of duplication in your yarn lock. And we have to use, we use a Webpack plugin to help, called Webpack deduplicate plugin, because that's really a problem in your bundle. Because if you have multiple copies of React loadable or React whatever, those, depending on how your dependency graph is, you might end up with multiple copies of that code in your bundles, and you're not even realizing it. And you have to put in Webpack plugins to protect against that bundle bloat. But one of the most cool things we did recently was a guy named Stanislaw put in a yarn deduplicate step at the end of our post install. So if you change a package JSON at the end of the install, it's going to run yarn deduplicate, and if you added a duplication, we break the install, and it happens in CI too. So it'll collapse those compatible Semver ranges into one range in your yarn log, which helps also with the install times, because then you're not installing like really close Semver ranges dozens, hundreds of times across your install process. You're able to collapse those down into smaller ranges. So that's really, really helpful too. So check out yarn deduplicate. Even like another thing we're working on right now is we're combining, this is just speaking of deduplicating, we're working on combining multiple monorepos into one. Each one of those monorepos has their own yarn lock, and what's so crazy is one of the tenants might have _051, the other one might also have _051, but because Semver, they resolve differently. One might be 052, one might be 060. And so as we're trying to combine those yarn installs, who wins? I don't know. And that makes it really hard. And seriously, like last week, we've been submitting yarn lock pull requests to merge them. We bumped a package from 051 to 052, and we're like, yay, it's just a patch version. And then it just like broke Word's automation pipeline for a few days. But that's because Semver's not that good. It's like based on human trust, and like apparently it's just not that good. You might think it's because it's patch, it's not going to break anything, but that's not entirely true. So I'm just telling you, Semver is really, really hard, especially at scale. So you got to be very careful with it. Managing your dependencies, kind of related to the yarn lock, one of the things that can help with the duplication problem is there's a lot of new tools out like SyncPack. SyncPack is a tool you can it's a little bit hard to see, but right in the middle there, see there's one of those that says 17.1.0, where everything else is 17.0.1. So if you want to align what we have to do, because we've got so many packages, we don't want like 50 versions of React ideally. We don't do this for every package. Well, actually, I think OUI does it for a lot of things, but we try to run SyncPack to try to keep certain packages in alignment if possible, like definitely the common ones. And in fact, we even have an entire team that handles our 5 most common ones: React, TypeScript, Jest, and a couple others. So they maintain like the big ones. Then there's tools like SyncPack that are really, really great. RNX Kit is something that sort of formed out of our React Native team, but they have a tool called Align Depths that's similar. And it just makes sure that the big dependencies stay aligned across the monorepo. Again, if things look and act the same, it becomes a little bit easier to manage the thing at scale. So those are a couple good tools for y'all to check out. Obviously, our build pipeline, 1,500 packages, is pretty big. So CI/CD at scale is pretty important. And the main way that we get around having that big, long build pipeline is by having a follow-the-sun support model. So I'm on call from 8 to 5, then somebody in Oslo jumps in on their time zone, and somebody in India jumps on in their time zone. So we have this continuous around-the-clock support, because that's the only way we can make a system like this scale. And back again to data. Man, data is key. You've got to have metrics about your pull requests, metrics about your releases, and then you can use that data to do alerting. So if our pull requests are starting to fail like a lot in a certain amount of time, we can go in and send somebody in to figure out like, okay, what's going on right now? You want to have that data so that you can do that alerting. And then another thing that like you may not think about a whole lot, but like each step of your YAML needs to be really fault tolerant, especially in your release pipeline. If you're pumping through your release pipeline and like you're publishing 50 packages, and suddenly at package 37 there's a network outage and your release pipeline exits, you've got to make sure that you can recover from that very easily, because you've got now your versions are out of sync. So you have to be constantly thinking about every single step of your YAML. Is this thing fault tolerant? Is it going to recover the next time I run this thing? Really, really important. And there is a lot of YAML. That's why I was joking earlier, like I'm not even a front-end engineer anymore. I'm just a YAML developer at this point, because it's just like 90% of what I deal with. And it's really important to generalize those steps too. Again, we don't want to have too many, one-off little pipelines here and there that nobody really knows and understands. We got to make sure that if somebody's introducing a change to the build system, that it's properly vetted and understood, and make sure that it works across all the packages in the repo. Testing at scale, another really hard problem. And honestly, we're still kind of working through this one. We have some things that we're doing. I don't know if you can shard your Jest tests by basically, we have test suites that have 8,000 tests in them, and that's really a lot of tests. And so you can shard them and maybe run like 800 tests on this box, and 800 tests on this box, and 800 tests on this box. That's sharding, and then distribution by running them on different machines as well, not just sharding even on the CPUs. Like spin up multiple machines to do your tests. And a concept, like how many people are doing visual regression testing where you're doing pixel testing? Okay, because if you've never heard of that, this is a really amazing piece of technology that, unit tests are great, and obviously you should be doing that, but stuff like end-to-end testing with Cypress and then this visual regression testing concept, it will literally take a screenshot of before and after your changes and then diff them. So one of our amazing developers, we were using Screener, but he actually wrote something called Pixel Buffer Diff. It's in there. His name is Mathieu. He's a French guy, friend of mine. And that, all the red there, it was showing before it died again, was the diff between one change to another. So it's really incredible technology that's able to kind of go in and see, and then that covers you like in a lot of, like what could have been hundreds of unit tests is now just one screenshot test. So, I mean, probably, again, you should probably still be. But in terms of UI testing, I mean, you can't get much better than that. That's amazing. So then there's things like for end-to-end testing. We've also got Playwright. I meant to link that. It's another open source tool that we use. So doing all that at scale, hard stuff. All right. That's all I have, but it won't even show me the conclusion slide. Scaling is hard. So is PowerPoint, and so is HDMI cords. So thanks for coming. In conclusion, I think the most important things are just to make sure you're continually talking, communicating, iterating, and improving. You can join the DevOps Discord and read the article on that, and then my blog. And yeah, thanks. Have a great rest of the conference. What's that?
If you could magically wave a wand and like be done with your yarn and only be on PNPM, would you do that, or do you find some value in
We're trying to, the question was if I could wave my magic wand and get off of yarn to PNPM, would I? We're trying really, really hard to just make NPM the standard. And that's why rather than just switching us to PNPM off of yarn, we're trying to make NPM better. We love that team. I feel pretty strongly that like NPM is the standard. And so I want that goodness that we have to be available for all of us. So that's why I'm trying. I mean, PNPM is great, and if you want to go use it, then definitely do. But for us, what we've tried to do is bring that goodness to NPM. So that's where we're at. Ask any more questions if you want. Oh, hey.
So it seems like one of the big advantages of PNPM is you kind of get like global cache that stops you having to pull stuff.
Yes.
Do you leverage that in your CI/CD pipelines at all, like on your job renders, or you cache?
Yeah. We are working on that literally right now. One of the things that we're working on is Azure DevOps lets us spin up our own agents, and those are, I think it's Azure, one of the templating languages. Anyways, so we can build our own agents and run a yarn install on the agents that pre-populates the yarn cache, and then we take that agent and provision it across the entire pool of agents. And so all the PRs get the same base image preloaded with the yarn cache, and then there's like not even a download. Then your yarn install goes from like 8 minutes to like 4 minutes for like thousands and thousands of things. So yeah, good question. Yeah, it is awesome actually. Yeah.
You mentioned using the Petabyte.
Yes.
How much do you let it run a while? How do you manage all the
Whew. Yeah. Oh. Yes, I'll repeat the question. The question was for Dependabot, how do you manage that at that scale? We have a lot of people that help do that, and so I get automatically alerted, especially for security ones. The main thing we use Dependabot for is we call it component governance. And so if there's a big security bug, they'll try to bump it and then say, hey, we need to go get you to make sure that you can get this fixed. So we just have a team that monitors it. And again, it's about letting us know what's going on and alerting. And it's just scale. The on-call engineers, against this, we have their follow the sun thing. Like whoever's just on call tries to handle a lot of those bumps. That's still a big one that we're even still working through ourselves at that scale. Yeah. Yes. So how do pull requests work? Is that kind of the? Yeah. Azure, we use Azure DevOps, obviously, and there's a couple things that we do. First of all, it's really smart in that the last person that reviewed it, they kind of keep asking that same set of people, but we also have rules. It's like these packages are owned by these teams, and so those pull requests are automatically added, or certain reviewers are added when certain packages change. So people can opt in to getting added to as a required reviewer based on what part of the code base changed. And then we also introduced the concept of ownership too, where every single package has an ownership.json file that lists the two email addresses to get in contact with people if you have extra questions on a package. So it's pull request policies and ownership. Cool. Thanks. You can come up and talk over here too if you don't want to ask if there's any other thoughts, questions. Woo!